Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. So here we are required to evaluate orthographic projections of an oblique line which happens to lie in the third quadrant. So here we have a line AB which is having its end A 10 millimeter from the vertical plane and 20 millimeter from the horizontal plane, whereas the end B of the line AB, it happens to lie 50 millimeter from the vertical plane and 45 millimeter from the horizontal plane, and the distance between the end projectors of the two ends A and B, it is equal to 55 millimeter. We are required to draw the front view projections, the top view projections and the left hand side view projections of the line, assuming the line to be lying in the third quadrant. Now since the line happens to lie in the third quadrant, so the end A, we are going to assume that it is going to lie 10 millimeter behind the vertical plane and 20 millimeter below the horizontal plane. Similarly, the end B, it will be lying 50 millimeter behind the vertical plane and 45 millimeter below the horizontal plane, and the distance between the end projectors will be taken as 55 millimeter. So with this information, we are going to proceed to evaluate the orthographic projections of this line. So here we can see front view will be drawn below the XY reference line, top view will be drawn above the XY reference line, and the left hand side view will be drawn using this particular transfer line over here, and this left hand side view will be constructed below the XY reference line and on the left hand side of the front view projections of this line. So here we have got the end A of the line. It is lying 20 millimeter below the horizontal plane and 10 millimeter behind the vertical plane. So 20 millimeter below the horizontal plane means that point A dash, it will be drawn 20 mm below the XY reference line. So point A dash will be lying below the XY reference line, while the top view projection of the end A, it will be lying 10 millimeter behind the vertical plane. So this 10 millimeter distance we are going to take above the XY reference line in order to obtain the top view projection corresponding to the end A. So here projections corresponding to end A, they have been obtained in the orthographic projections. So having obtained the projections corresponding to the end A, another information we have got, the distance between the end projectors of the two ends A and B of the line AB, they happen to be 55 millimeter. So this distance happens to be 55 millimeter. So please check. Here we have marked the distance between end projector of the end A and the end projector of the end B over here. So here this distance between the end projectors of the point A and point B of the line AB, it happens to be 55 millimeter. So once we mark this distance 55 millimeter, we are going to draw another vertical projector line at a distance of 55 millimeter from the projection line corresponding to the point A over here. That is, onto this particular vertical projector line, the front view and the top views corresponding to the end B of the line will be located. Now here we have got the coordinate locations corresponding to the end B, that is the end B of the line. It lies 50 millimeter behind VP. So 50 millimeter distance behind VP, it will be drawn above the XY reference line in the quadrant number 3. So point B will be located at a height of 50 millimeter from the XY reference line measured above the XY reference line. So this way point B projection, that is the top view projection, has been located onto the orthographic projections. And another information we have got that end B, it is lying 45 millimeter below the horizontal plane, because we have assumed that this line happens to lie in the quadrant number 3. So the distance of the point B from the horizontal plane is 45 millimeter below the horizontal plane. So we are going to obtain the front view projections corresponding to the end B 45 millimeter below the XY reference line. So point B dash will be located onto the same projector line where point B was located. So point B was located over here. So onto the same vertical projector line, we are going to obtain the projections corresponding to B dash. That is the front view projections corresponding to the point B. Now having obtained the front view projections A dash and B dash corresponding to the line AB, and the top view projections of the line AB into the orthographic projections, now we can join A with B and A dash with B dash over here. Now AB projection line, it represents the apparent length top view projections of the line AB. Similarly, A dash B dash, this projection line, it represents the front view apparent length projections of the line AB, which are represented onto the vertical plane. So having obtained the front view projections A dash B dash and the top view projections as AB over here, now we will proceed to evaluate the left hand side view projections of this line AB. So in order to obtain the left hand side view projections of this line, which happens to lie in the third quadrant, so please see here, whatever is the distance of the point A with respect to the horizontal plane, that is, it is 20 millimeter below the horizontal plane or below the XY reference line. So even in the side view, this distance will be below the XY reference line. That is, point A double dash will also be lying onto this particular horizontal locus line. Similarly, whatever is the distance of the point B in the elevation, that is B dash, below the horizontal plane or below the XY reference line, that is equal to 45 millimeter. So we have to draw a horizontal projection line in such a way that onto this horizontal locus line corresponding to the point B dash, our point B double dash will also be lying onto the same horizontal locus line. So the distance of the points A and B in the elevation, they will decide the locus lines for the points A double dash and B double dash in the profile plane over here. Now we have to mark this distance of the points A and point B from the vertical plane, and this distance of these 2 points A and B from the vertical plane, we have to transfer it from the top view projection into the side view projection over here. So please check, here we have got the distance of the point A with respect to the vertical plane. It was provided to us 10 millimeter behind the vertical plane. So this distance of 10 millimeter behind the vertical plane, that is obtained in the top view. So this we are required to transfer it into the profile plane. So wherever this horizontal projection line drawn through the point A of the plan, it intersects with the transfer line. Now from this particular position, we have obtained a point onto the transfer line corresponding to the point A of the plan. Now from here, we have to drop a vertical projector and extend this projector in the downward direction till this projector intersects with the horizontal construction line which has been drawn through the point A dash over here. So wherever we obtain the intersection of these two projection lines, we are going to obtain the location of the point A double dash over here. So now please check, if we look at the coordinates of this point A double dash, this point A double dash happens to lie 20 millimeter below the horizontal plane and 10 millimeter behind the vertical plane over here. So this way the coordinates of the point A double dash have been obtained. Similarly, we know that wherever point B dash is located in the elevation, so corresponding to this point B dash, so we have already drawn a horizontal construction line which is going to determine the location or the position of the point B double dash in the left hand side view projections over here. Now we know that this locus line, it is giving us 45 millimeter distance below the horizontal plane in the profile view projection over here. Now we have to transfer this distance of the point B, that is the distance of the point B in the plan. So this distance is how much? 50 millimeter. So we know that point B or the end B of the line, it happens to lie 50 millimeter behind the vertical plane. So we are required to transfer this distance from the top view into the profile view projections over here. So now what we have to do to convert this distance from the top view into the profile view projection, we have to draw a horizontal projection line emerging from the point B in such a way that we have to extend this line till it meets the transfer line which has already been drawn at an angle of 45 degree. So moment this construction line emerging from the end B, that is in the top view projection over here, it intersects with the transfer line. So one point corresponding to the plan projection B has been obtained over here, and from this point we are going to drop a vertical projector in the downward direction in such a way that we have to extend this vertical projector line till this particular vertical projector, it meets the or it intersects with the horizontal projector line which had been drawn through the point B dash of the elevation. So once we obtain the intersection point of these two projection lines over here, the location of the B double dash point has also been obtained. Now we can check the coordinate locations of B double dash. So B double dash point is obtained in such a way that point B, it happens to lie 45 millimeter below the horizontal plane and this distance happens to be 50 millimeter. So it lies 50 millimeter behind the vertical plane. So this way the conditions corresponding to the end B which was stated to us in the problem, they have been satisfied. So A double dash point has been obtained, B double dash point has been obtained. So we can join A double dash with B double dash point. So this provides us with the left hand side view projections of this particular line AB which happens to lie in the third quadrant. So this way, so using the basic fundamentals of the orthographic projections of the line, so we have been able to obtain the front view projections of the line, the top view projections of the line, as well as the left hand side view projections of the line AB which happens to lie in the third quadrant. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how we can go about evaluating the projections of the line when the line is assumed to be located in the third quadrant. So we will be continuing with further discussion upon more illustrative cases related to the projections of the lines in the coming lectures. So thank you very much. Thanks a lot.